Welcome to our video part 3. First you have to see video part 1 and 2 to understand sequentially about these computer hardware components. Then click the link present in description. Let's get started. The power supply unit PSU serves as the heart of a computer's power system. Its main function is to convert the alternating current AC power from the wall outlet into direct current DC power, which the computer's components require to operate. This conversion ensures a stable and consistent power supply to the various hardware components within the computer. Wattage. The wattage of a PSU determines how much power it can supply to the computer's components. It's essential to choose a PSU with adequate wattage to support the power requirements of your hardware, including the CPU, GPU, drives, and other peripherals. It's recommended to calculate the total power consumption of your system and choose a PSU with a wattage slightly higher than that to ensure stability and avoid overloading the PSU. Efficiency ratings. PSU efficiency refers to how effectively it converts AC power from the wall outlet into DC power for the computer. Efficiency ratings are typically labeled as 80+ certifications, such as 80+ bronze, silver, gold. Cooling systems are crucial for maintaining optimal temperatures within a computer to ensure the longevity and performance of its components. Excessive heat can lead to thermal throttling, reduced lifespan, and even permanent damage to hardware components. Air cooling. Air cooling is the most common and cost-effective cooling solution for computers. It involves using fans and heat sinks to dissipate heat generated by the CPU, GPU, and other components. The CPU typically has a heat sink with fins that help dissipate heat, and a fan blows air over the fins to carry away heat. Similarly, GPUs often come with fans attached to the graphics card for cooling. Additional case fans can also be installed to improve airflow within the computer case. Liquid cooling. Liquid cooling, also known as water cooling, is a more advanced cooling solution that uses liquid coolant to transfer heat away from components. Liquid cooling setups consist of a pump, water blocks, tubing, a radiator, and fans. The water block is placed on the CPU or GPU, and the pump circulates coolant through the system. The coolant absorbs heat from the components and carries it to the radiator, where fans dissipate the heat into the surrounding air. Liquid cooling systems are typically more efficient than air cooling and can offer better thermal performance, especially for overclocked components or high-end systems. 1. Central Processing Unit CPU. The CPU acts as the brain of the computer, executing instructions and processing data. It fits into the motherboard CPU socket. 2. Motherboard. The motherboard is the main circuit board that connects all components together. It provides slots and connectors for the CPU, RAM, GPU, storage drives, and other peripherals. 3. Random access memory RAM. RAM temporarily stores data and instructions that the CPU needs to access quickly. It slots into the motherboard's RAM slots. 4. Graphics Processing Unit GPU. The GPU, or graphics card, handles rendering images and videos. It can be integrated into the motherboard or installed as a separate card into a PCIe slot. 5. Storage drives. There are different types of storage drives like HDDs, hard disk drives, and SSDs, solid-state drives. They store data permanently or temporarily and connect to the motherboard via SATA or M.2 ports. 6. Power Supply Unit PSU. The PSU converts AC power from the wall outlet into DC power to supply to the computer's components. It connects to the motherboard and other components through various power cables. 7. Cooling System. Cooling systems, such as fans and heat sinks, or liquid cooling solutions, maintain optimal temperatures for the components to prevent overheating. Tips for building or upgrading a computer system. Ensure compatibility. Check that all components are compatible with each other and fit the motherboard socket types and form factor. Consider performance requirements. Choose components based on your intended use, whether it's gaming, content creation, or general productivity. Plan for future upgrades. Select a motherboard and PSU with room for expansion and future upgrades. Research benchmarks and reviews. Look for benchmarks and reviews of components to gauge their performance and reliability. Budget wisely. Allocate your budget based on the components that will have the most significant impact on performance for your specific needs. By carefully selecting and assembling compatible components, you can build or upgrade a computer system tailored to your requirements. That's it guys, thanks for watching. If you like to love these video then like, share and subscribe. Bye bye, take care. Last but not least, knowledge is a power.